Hello everyone. Today, let's solve an intriguing problem from SuMON program, Fortnight 11. This problem is about algebraic equations, but we are going to proceed through graph by plotting a graph of a certain function. So this graph is going to increase and decrease, and we are going to use that property to solve this problem. So this is going to be a non-routine way of approaching algebraic equations, and I hope you will enjoy it. Let's get into the video. So here is the problem that we are going to discuss. As you could see, we have an algebraic equation, and the second condition is about xyz being equal to 1, and we are asked to prove that x equals y equals z equals 1. But we also need to use the condition that x, y, z are positive real numbers. We will be using a bit of differentiation here. So stay tuned. Let's get started. We know that yz can be written as 1 by x. So substituting that, we get 1 plus x whole power 4 by x. And that equals 1 plus y whole power 4 by y, because xz equals y. And similarly, 1 plus z whole power 4 by z. And let's take the reciprocal of these. So this implies x by 1 plus x power 4 equals y by 1 plus y power 4 equals z by 1 plus z power 4. And as you can see, the form of each of these expressions is the same. So let's try to plot the graph of this function, and let's analyze the functional value being equal for three numbers x, y, and z. So what is the function that we are going to consider? It is trivially the function f of x equals x by 1 plus x power 4. Remember that the denominator is only raised to the power of 4. Let's not try to plot this directly. We know differentiation helps in finding the slope of the graph becoming 0, the point at which the graph bends, or local maxima or min. So this helps us to plot the graph, right? So let's try to find the point at which the graph bends. So let's use some differentiation here. What's f dash of x? It is the differentiation of numerator, which is 1, times the denominator, minus differentiation of the denominator times the numerator by 1 plus x power 8, because we have to square the denominator separately, which will be our new denominator. Now this equals 1 plus x the whole cube times 1 minus 3x. So I'm just taking common 1 plus x whole cube divided by 1 plus x whole power 8. So guess the point at which the function has a slope 0. It would be nothing but the point with x coordinate 1 minus 3x equals 0, or equivalently, the point at which x equals 1 by 3. Since x is a positive real number, 1 plus x cannot be 0. So let's not worry about that, because this is nothing but 1 minus 3x by 1 plus x power 5. So the graph has taken a turn at the point x equal 1 by 3. But we are not sure whether this turn is a local minima, that is curving like this, which looks like some convex function, or curving like this, which looks like a concave function. In order to determine that, we can again analyze the function obtained after differentiate, which is 1 minus 3x upon 1 plus x whole power 5. Now if x is less than 1 by 3, clearly this value goes above 0. And if x is more than 1 by 3, this value is negative. Implies the slope is negative, and if x is less than 1 by 3, implies the slope is positive. But what is the meaning of slope being positive? It means that the graph is increasing before x equal 1 by 3. And the graph is decreasing after x equal 1 by 3. So we may predict the graph, and also f of 0 is 0, which is trivial. We may predict the graph of f of x using these ideas. That is, it is increasing till 1 by 3 and decreasing thereafter. So we have the actual graph, and I will show that to you. It is quite appealing, isn't it? Because we see the same characteristics are preserved, which is exactly what we predicted. As you can see, the blue line is the graph, and this thick line is the x-axis, and the vertical thick line is the y-axis, and you can see the graph is like this. It peaks at x equal to 1 by 3. Alright, so where are we going to use this logic when it comes to the equation f of x equals f of y equals f of z? Because remember that our equation is written in terms of the function f. It's the value taken at y, this is the value taken at z, and this is the value taken at x, and all three are being equal. So what do you guess? Suppose if you consider any functional value, which is of course greater than or equal to 0 and less than or equal to 0.1055, because we have to stay within the minimum and maximum. Now when you consider a value, it clearly corresponds to two values on the graph. So it can correspond to at most two distinct values of x for which that particular functional value is obtained. But we have three values, x, y, and z. So hence all three can't be distinct. So we conclude that sum 2 of x, y, z must be equal. This is the analysis and the result from the graph. So let's now go back to the algebra. If sum 2 of x, y, z must be equal, we may assume without loss of generality that x equal y. This won't harm our generality. So coming to the equation, we have one equation as x by 1 plus x whole power 4 being equal to z by 1 plus z whole power 4 and x square z equal 1, because now x is equal to y and I have substituted y as x. So we can derive that z equals 1 by x square, and let's substitute it back in the first equation that we wrote here, the equation numbered 1. If we substitute z as 1 by x square, we get x by 1 plus x whole power 4 equal to 1 by x square divided by 1 plus 1 by x square, and this can be rewritten as x power 5, or actually x power 6 by 1 plus x square whole power 4. I'm just taking the x square from the denominator to the numerator. So now this simplifies to 1 plus x square whole power 4 being equal to x power 5 into 1 plus x whole power 4. This implies 1 plus x square whole power 4 equal to x into x plus x square whole power 4. Let's now use some inequalities to arrive at some conclusion, because these two can be compared in a different way when x is less than 1 and greater than 1. They can't be equal. So let's do that. How to invoke inequality here? Let us assume x to be less than 1. Alright, if x is less than 1, let's add x squared to both sides. It will still be lesser. Adding equal amounts in an inequality, do not flip it. Raise it to the power of 4, because I know that x is a positive real number as given in the question. Now we have also x less than 1. If you multiply these two inequalities, and of course since they are of same sign, we can multiply them, that's allowed. So x into x plus x square whole power 4 would be less than 1 plus x square whole power 4, which means the equality cannot hold here when x is less than 1. Now let's assume x to be greater than 1. Let x be greater than 1. Now follow similar logic to obtain x plus x square whole power 4 is greater than 1 plus x square whole power 4. And we also know x is greater than 1. Multiply the two inequalities to get x times x plus x square whole power 4 to be greater than 1 plus x square whole power 4. Again, equality can't hold. So we need to have x equal 1. But would x equal 1 be consistent with the equality? Let's check that out. If I substitute x equal to 1, both sides would equal 16 and thus equality hold true. So we conclude that x equal to 1. So see how graphing the equation and dealing with inequalities with that equation are all helping an algebraic equation to be solved. So if x is equal to 1, we can say that z also equals 1, because z is 1 by x square after all, which is 1. So thus we have proved that x equal y equals z equal 1, and this of course satisfies the given algebra. So this is the essence of using various other concepts in a different concept to solve it. So try to be open-minded, and I hope you enjoyed this video. The link of this board work will be available in the description. You can download it. Happy learning. Thank you all.